Okay, so like I said before class kind of started, where we're at here, we're going to finish 7-3 today. Wednesday, we're going to review, and I've already given you that review packet. You can also find that on Blackboard. If you go into Blackboard, pick on your college algebra class, lecture handouts and lectures. Scroll down to chapter 7, and you can find the review, which is a PDF, and at the end of the PDF, it gives you the answers to the problems. So these are from the book. The 1 through 8 is asking you to do 3 parts to it. Now, not all the questions will be like that. It might just say, what is the vertex? What is the center? What is the shape? Is it an ellipse? Is it a hyperbola? Is it a parabola? So you should be able to already kind of identify what shape this is. What shape is one? Ellipse.
Ellipse is plus.
Both of them are squared and it's plus. Hyperbola is minus, like 2. You see how they look very similar? The negative. So it's a hyperbola, and it tells you if it opens up or down or left or right. The ellipse, the larger number tells you if the major axis is the x or if the major axis is the y. And then, of course, there's shifts. You can deal with that. This is a ellipse. What about 4? Both of them are squared. Parabola is only one of them is going to be squared. And you. Yes. Good. They're both positive in this list. What about 9? Sorry, 5. The minus 9 gives you the hint there. It's a hyperbola, right? What about 6? Ellipse. 7? 8? Only one of them squared. Parabola. Hyperbola is going to be when they're both squared, but one of them's negative, right? So like 2 and 5, right? So the very first test is, can you just identify the shape? Don't do anything with it. Can you classify these as ellipse, hyperbolas, or parabolas? If only one of the variables is squared, it's automatically a parabola. If they're both squared, it's an ellipse or a hyperbola. If they're both positive, it's the ellipse. One of them's negative, it's the hyperbola, right? Then you go from there and say the center. Pretty straightforward, the center are on 1, 2, and 3. 4, 5, and 6, you have to complete the square. So a little bit more time consuming. And 8, you have to complete the square as well. And then also you'll be asked to deal with general information about the graph coming up with the standard form, right? So it says the equation of the ellipse. So you know it's going to be something squared plus something squared, right? And there's some shifts there. And there's a over b, and that equals 1. Correct. 3 is a parabola. I don't know if we said ellipse. Sorry. Yeah, it would be a parabola. It's only one of them squared. They're both squared. So 1, 2, and 3 gives you examples of ellipse, hyperbola, and parabola. 4, 5, and 6 make you put it in standard form. So you have to complete the square.
But you don't have to just recognize the positive.
You could if I just asked you to classify it, yeah. But a lot of times there will be put it in standard form. So you have to end up completing the square and dividing through by whatever number it equals to get that to be 1. And then, of course, on this, it's going to expect you to graph it, because I could give it to you in standard form and have you graph it. And then 9, 10, 11, and 12, here's information about the graph, put it in standard form. So you need to be comfortable going both ways. So let's finish practicing 7-3. Question? Yeah, let me see if I have an extra copy. I think I do. Anyone else need a copy of 7-3? Thank you so much. So 7-3, we did some examples. We finally got to the part where we did shifts. And we did a couple examples there. And then we left off with completing the square of a parabola. Now, in completing the square of a parabola, you're only going to have to complete one square, the thing that's squared. Everything else, you just pull on the other side. And you always want the coefficient in front of the squared term to be 1. So you need to divide through that if it needs to be. So write the equation in standard form. So the x term is what's going to be squared, right? So I move everything else to the other side. 4 x squared minus 20x equals 8y minus 57. Now on the left-hand side, I want to complete the square, so I need to pull out that 4. So I have 4x squared minus 5x equals 8y minus 57. Does everyone see what happened there? What do I need to add to the left-hand side to make it a perfect square? Yeah, it's not as pretty as we're used to, right? But it's still a number. If I add 25 over 4, I'm really adding 25 over 4 times 4, right? So if I add 25 on the left-hand side, I'm really adding 25 on the right-hand side as well. I got to keep it balanced. So that's probably the common mistake students make when they can go to complete the square. They do it on the left-hand side perfect, but they forget about the right-hand side.
So you don't put it over 4?
You do put it over 4, but then you multiply it by 4. Right, because this 4 out front, I multiply it. It's actually just plus 25 here. I'm adding 25 over 4 inside the parentheses, but when I add it inside the parentheses, I'm really adding 4 sets of that. So here, what is my perfect square? X minus 5 over 2 squared. You see that? Equals 8y minus 32. Now I want to pull out that 8. So I want to get this truly in standard form. So before I pull out the a, I'm going to divide through by this coefficient here, 4. Do you guys see that? So x minus 5 over 2 squared is going to equal 2y minus 8. And one extra step I need to do. Pull off the 2 and get y minus 4. I could go one step further and write this as 4 2 over 4 y minus 4. And that would just tell me what p is. This is p. Do you guys see? Because you remember that the 4 is out front. So this is in standard form. This is just one extra step to see what p is, right? These are fractions, so they're not as pretty to deal with, but we still deal with them the same way. Well, my answer key here. So, what is the vertex? 5 over 2, comma, is it 2? 4, right? So if I was to graph this, I go 5 over 2, 1, 2. 5 over 2 would be 2.5. So 1, 2, 3, 2.5. 1, 2, 3, 4. So I'm just going to say this is 5 over 2, comma 4. Which way is this opening? The x is squared, right? And the coefficient is positive. It's actually going to open up, right? Remember the general formula, y equals x squared, that opens up. You guys remember that? So if the x is squared, it's opening up or down, depending on the coefficient in front of the y. Right? You guys convinced that? So this is my vertex. I'm opening upward. So my x values on this line is all going to be 5 over 2. The p in this case is 2/4, which is the same as 1/2. So if I move up a half, I'm at 5 over 2 plus 4 plus a half, 9/2. So this is my focus point. Would be 5 over 2, comma 9 over 2. Yes. You guys see that? Focal diameter is always 4 times p, which in this case is, well, 2/4 times 4, right? 4p. P is 4 over 2, so this would be 2. Would be 2. If I wanted to graph the endpoints, that means I go to the left one and to the right one. Maybe not parentheses here, it's just 2 units. They don't ask for the endpoints, so I'm not going to necessarily graph them there. But they would be 5/2 minus 1, which would be 3/2, comma 9 over 2, because my y is not changing. 5/2 plus 1, 7/2, comma 9 over 2. So don't be intimidated by fractions. They work the exact same. You just have to add the fractions. Know when you're adding only the x and leaving the y alone. Know when you're adding or subtracting only the x and leaving the y alone. Any questions? Well, you guys work on the next one. It's along the same lines. You're going to have to deal with fractions. First thing you need to do is complete the square. Get it in the general form. So the coefficient in front of the x and the coefficient in front of the y should be 1. Sign-in sheet go around. Everyone get it? it's minus 21 if I put it on the other side.
Yeah, but you got -12.
Because it's minus 12 here, so I add 12. So I add or subtract everything else. It doesn't have an X in it to the right-hand side. So if it's minus 12 on the left-hand side, it's plus 12 on the right-hand side. If it's plus 21 on the left, it's minus 21 on the right. These take practice. So you could actually find the endpoint of the lattice rectum. The endpoint is just kind of help you graph it. When you just put this right here, put this right here, and put a line, it just helps you see how wide it's going to be. But this is just basic shape. You can do it to give you knowing that it's going to open upwards from that point. Since the x is the squared, it's going to open upward. The y was squared, it would open left or right, depending on the coefficient in front of the x. So I add 9 over 4, but I'm really adding 9 over 4 times 4 because the 4 is out front. So when I add that to the right-hand side, I have plus 9. So minus 21 plus 9 is a minus 12. Minus 21 plus 9. Minus 12. Okay, so focal diameter is just 4 times p. It's always this number here. 3. So it means you're adding 1.5 to the left and 1.5 to the right. But knowing the focal diameter, yeah. Okay. Those are good. Yep, those are good. So really the graph really helps you visualize. Am I moving up? I'm moving up, I only change the y value. The x values are going to be the same. I'm opening to the left or the right, then my y values are all going to be the same, and I'm only changing x. The p tells you if you go up or down. Your focal diameter is always positive. Sometimes it's almost easier to graph it without coordinates. So I know this is going to open up. My focus is going to be p units up from my vertex because this opens up. So that means I'm only going to change the y, and I change the y by 3 over 4. So I have 3 halves, comma, 1 plus 3 over 4, which is 7 over 4. My vertex point. My focal diameter is going to be a distance of 3. Here, the focus point, I know this opens up because the x, 7 over 4 would be 1 plus 3 over 4. Because my vertex is at the y component of 1. I'm going up a p unit, and p unit is 3 over 4. You always factor out a 4 here to find what p is. So if this is 3, then p would be 3 over 4. So this would be 7 over 4. If I wanted to go one step further and find the endpoints, if this whole distance is 3, then this distance is 1.5 and this distance is 1.5, right? And I could write that as 3 over 2. So if I'm at x equals 3 over 2 and I subtract 3 over 2, I'm at 0, comma, 7 over 4. 7 over 4 doesn't change. The y component on this line is always 7 over 4. If I'm at 3 over 2 and I add 3 over 2, they give me 6 over 2, which is 3, comma, 7 over 4. So it didn't ask for the endpoints, but they're easy enough to find once you know the focal diameter. The focal radius will be half of that. So you take your focus point and add P and subtract P from the x value, because the x is what's changing. The y is always the same. Do you see that? The last thing we're going to go over here, given information, find the equation. Does anyone have any questions in the previous? Again, I'm not going to have you go from non-standard form to a graph, because if you can't get it in standard form, then your vertex is going to be off, your focus is going to be off, everything's going to be off. So there's no point in having you go through those motions. What you'd be tested on here is take an equation of a parabola and put it in standard form. So once you get down to this point, that's how far I'm going to test you on the exam. Now I might give you it in standard form and have you graph it, but you're going to be given standard form, have you graph it, or just have you put it in standard form. So here it tells us we're given a parabola, we're given the focus and the dextrous line. So if I come here, the focus is at 1, 2. The dextrous is at x equals 7. Oops. So let's put it on the coordinate system. 1, 2. The dextrous at 1, 2, 3, 4, 5, 6, 7. This is the focus. So the vertex is going to be halfway between the focus and the dextrous line, right? What point is halfway between 1, 2 and x equals 7? Right, this distance is 6. So cutting that in half would be 3. So 3 units to the right of this point, which would be 4, 2. So that tells me what P is, and P is 3, right? It has to open to the left because I have the focus and the dextrous. It always opens towards the focus. So my center, let's see if I can write this a little better. 4, 2. So what component is squared? The y, right? So I have y minus 2 squared equals, P is 3, right? So if I have 4, is P positive or negative? Negative, right? Negative 3 over 4. No, P is 3. Minus 3. And then what's the shift in x? X minus 4. Really, the only thing you need for a parabola is P and the vertex. And you can find that by knowing the focus and the dextrous and halfway between that, then knowing the equation, knowing that the y component is squared, and knowing that P is really negative 3. So the general form would be y minus 2 squared equals minus 12 times x minus 4. I want you guys to try the second one. It's the very same setup. I give you a focus and a dexterous, and you put it in the general form. P is the distance from your vertex to your dexterous line and the vertex to your focus. So in this case, it's halfway between, we were given the dexterous and the focus, so the vertex is halfway between that. So the total distance is 6 and P is 3. So very similar on the next example, except so P is 2. In this case, it'd be minus 2 because you want to focus down. So once you have the center, and once you have P, you plug it in the equation. Huh? Which is something you should be comfortable with knowing that basically you can always think of y equals x squared or x equaling y squared. This is going to open up or down depending on if this is plus or minus, plus or minus. This is going to open left or right depending on
Y squared left to right, X squared up and down.
yes. And you can remember the very first parabola you learned was probably y equals x squared, right? So sometimes students will switch them and say, oh, the x is squared, I'm going to open to left or right. But it's actually not. It's y equals x squared opens up or down. But if you remember the very first one, the basics, that if the x component is squared, it's going to open up or down, right? If the y component is squared, I'm opening left or right. So here I'm opening to the left, so I square the y component being shifted. So here, what do we end up with? Y equals 7. 1, 2, 3, 4, 5, 6, 7. So this is my dexterous line. The focus is at minus 2, 3. So minus 2, 3. Minus 2, 3. That's my focus point. Halfway between my dexterous and my focus is my vertex, right? So this is 1, 2, 3, 4. So this point is minus 2, 5. So that tells me this distance P here is 2. Then I know I open down, and I have everything I need. I have my center, and I have my P, right? The x component is what's squared. So I have x plus 2 squared equals 4 times P. I'm going to go ahead and write just P real quick. Y minus 3. Here, P is either positive or negative. It's opening up or down. Here, in this case, P would be minus 2. So my equation, what? Yes, thank you, because this is my vertex. Sorry about that. This is my vertex, not this. Minus 2, 3 is my focus point. So this is y minus 5. So this would be minus 8, y minus 5. So P is minus 2. The center, minus 2, 5. Sorry, the vertex. The focus is given. The dexterous line is given. Any questions on that? The general form is x minus h squared equals 4p y minus k, or this is for one that opens up or down.
So 1p by whatever the constant.
P is the distance from the vertex to the focus or the vertex to the dexterous. So here's the two things, right? These are the general form. The x component is squared if I'm opening up or down. So all you need to find is the vertex and P. And then knowing which general form it is in. Is it an x squared or a y squared? And it's always 4 times P. The focal diameter is always 4 times P. P is the distance from the vertex to the dexterous and the vertex to the focus point. So let's pull up Alex since we have some time. And let's see what Alex wants from the homework. I always forget my. Student view. These are the assignment, these are the Alex type questions for 7-3. There will be 3 questions, right? And they're all quick retakes, so no excuses, right? So graph the parabola. So the first thing we're going to have to do is complete the square. Is it going to open up or down? Y equals x squared opens up or down, right? What? So is it open? So it's a parabola, so it opens left or right. So is it going to open left or right? Well, we don't know, right? We want to probably factor out some things and get it in standard form. So let's see what we end up with here. What is my first step I want to do? Isolate the y's on the left-hand side, everything else on the right-hand side. So if I factor out a 3, I have y squared plus 2y equals x plus 2, right? So it's looking like it's going to open to the right. We don't know 100% yet. What do I need to add in here? 1, right? 2 over 2 squared. When I add in 1, what am I really adding in? I'm really adding 1 times 3, right? So here, this would be 3y plus 1 quantity squared equals x plus 5, right? The next step would be to divide through by 3. So I have y plus 1 squared. I'm going to write this as 1/3 x plus 5, right? You guys see that? So I could write this y plus 1 squared. If I wanted to put a 4 here, I would want 1/3 to be left, so I need to put 1/3 times a 4th. Really a 12th. P ends up being a 12th. But I don't know if we're going to need that. right? 4 times 1/12 is a third. Right, so this would be P. And it's positive. This is just an easy way to get P, to put it in this form. This is the general form. So my vertex is what? -1 minus 5. It is opening to, oh, thank you. Yes. -5, -1. The x component goes first. -5, -1. So if I go back to Alex, I graph that by picking the parabola, place the vertex. The vertex was at -5, -1. Am I remembering that right? Then I can choose the orientation. Which way is it going to open? The right. So I click on the orientation and place another point. So I need to place another point on the parabola. Right? So it's a little bit different than the way we would graph it because we'd find the focus. So we could find the endpoint, or we can plug in any x value and solve for the corresponding y. Right? Or I could plug in with y equaling 0, what does x have to equal? If y was 0, so if y equals 0, what would x have to be? -2? So y equals 0, x is -2. So -2, y equals 0, -2. Y is 0. Going back here. This is the original parabola. At y equals 0, we would have -x -2 equals 0. So if I add x to both sides, it's at x equals -2. So -2, 0 should be a point on the graph, on the parabola. So did I find that point? X is -2 and y is 0. We'll see how this works out. Next question. Find the equation of the parabola with vertex given and the focus given. So going back here, the vertex is given and the focus is given. So if this point is -1, 4, the focus would be 4, 4. So 4, 4, meaning it's going to open to the right, because you always open towards your focus. If I'm at -1, 4, and my focus is at 4, 4, then P is 5. Because I'm only changing the x, and I go from -1 to 4, so P is 5. So the y component is squared here. So I have y, this is the vertex, so I have y -4 squared equals 4 times 5, x plus 1. You guys agree with that? So I can put 20. So y -4 squared. So going back to Alex, I have y -4 quantity squared. Yeah. Equals 20 x plus 1. Is that what I had there? The last question here, find the focus. So be careful once the focus or the vertex. So this is asking for the focus. So completing the square, I end up with y squared minus 8y equals -5x minus 6 minus 8 over 2 squared means I'm adding 16 here. If I add 16 to the left-hand side, I have to add 16 to the right-hand side. This would be y minus 4 quantity squared equals minus 5x plus 10. Y minus 4 squared equals, if I factor out a minus 5, I have x minus 2, right? So that would be the vertex, and I want the focus. So if I put a 4 here, then this would be minus 5 over 4 to get a 5. So this is P. This is x minus 2. So we know the vertex is at x equals 2 and y equals 4. This is going to open to the left, right? The y component is squared and p is negative. So y component squared means I open left or right. The p is negative, I open to the left. P is 5 over 4, so it means this point would be 2 comma 4. So the 4 doesn't change, only the 2 changes, and I subtract 5 over 4 from it. So what's 2 minus 5 over 4? Which would be 8 over 4 minus 5 over 4, which would be 3 over 4. So this point is 3 over 4 comma 4. If I did that right. So 3 over 4 comma 4. Yeah. Wants to know the focus. Submit it. And we're good. So there is a little disconnect in the graphing one because it doesn't ask you what the focus is or the dexterous line. It asks you for the vertex and a point on the curve. So you can plug in any x point and find the y point, or any y point and find the x point. So this one, there was a little disconnect from how we do it on paper, right? We find the vertex, and when we find the focus and the dexterous line, find the latus rectum, things like that, you're going to need tests on. Alex doesn't really show you that. But there's only 3 questions on this homework, so I think review for the exam 4. Exam 4 will be on Monday, which is also going to be on the final 25% of your final exam. So we'll start then studying backwards from exam 1, exam 2, exam 3 next week. Friday. Well, did I? I'm sure I have exam in one of my classes on Monday. Sorry, guys. I will see you guys Wednesday for our review. So if you spend time on the review before you come, I think that will make Monday or Wednesday's class a little more beneficial to you than if you just try come on Wednesday and work on it. So